So starting with section 112, that's organic chemistry. You might think that you know this course from secondary school, that you have done organic chemistry and the likes, but you have to be very careful with this course. You have to be extremely careful. Read your notes, read textbooks. And the textbook that I'm going to suggest for this particular course is Organic Chemistry by Paula Yokanis Bruce. So that's the textbook. You might have other textbooks, but this is the one that I'm very sure of, that is very good. And whatever you get from this particular book, I don't think it can be wrong. I don't think they can be wrong in this particular book. So you might have errors of maybe typo or error in originality of the knowledge. Everything is there. So if you have this book, is actually very good for your CHN 112. So but don't read the book alone. Make sure you read your notes. Then whatever topics that you have read from your notes, you can go and read further about it from this particular textbook. Organic Chemistry by Paula Yokanis Bruce. That's the best textbook that you can read for CHM 112. Then read your notes, solve past questions, try to get seniors that have done the course, and they should tell you more about the course. The course is not very easy. It's not very easy because there are things that so be thinking that you know the course because you have done it from secondary school, but you're actually going to face a lot of problem if that is your mindset, that it is the same thing that you did from secondary school. And the problem here is that this is more advanced, and you don't even know whether what you were taught in secondary school is wrong. There are a lot of things that I knew from secondary school about organic chemistry, especially when it comes to the aspect of naming of organic compounds. That I actually thought they were the correct thing, but it was when I started reading that particular textbook that I knew that it was the wrong thing that I have learned. So and you might even skip that part, thinking that you already know it, but not knowing that what you actually knew is wrong. So it's important for you to review everything you know, anything that you see from section 112, and you think that you know it before. Please don't assume. Read it again from the book and make sure that you learn it the correct way. If it corresponds with what you know, that's fine. If it doesn't correspond, make sure you adjust your knowledge in accordance to what is inside this book. So that's one major reason people don't do well in CHN 112. They'll be like, it's not organic chemistry that we have learned from secondary school. They even skip some part that this part I already know it. But that's not the case. So you have to be very careful with this course. So your practical chemistry, I don't think there's anything special with practical chemistry. What you are going to be doing around this time around is qualitative analysis. There's no calculation here at all. Qualitative analysis instead of quantitative analysis. Then another thing I forgot to say about CHN 112, please, this is not a course where everything is all about cramming. Although there are a lot of part of it that you have to memorize, but before you even memorize, make sure you know the reason why that thing is like that. Because when you get to the exam, or most of their options are usually similar, they usually give very similar options, such that what you even cram, you might misplace it. Then it will now you now be left with, what do you understand about this particular stuff? So that's why it's very important for you to understand every aspect of the course. Try to understand every aspect of it, not just memorize it alone. So this one is all about qualitative analysis, and everything you need is inside your practical manual. I don't think there is any special thing in CHM 116. Then for CHM 132, you also need to understand it. There are little calculations from CHM 132. There are little calculations from it, like when you want to calculate the radius, the radius of an atom, the length of a unit cell, stuff like that. So you have to know all those aspects of the course. Then your periodic table, make sure you are very familiar with the periodic table, especially memorizing the elements in accordance with their groups. Try to know most of the elements, try to know the groups that they belong to, and try to know how to write electronic configuration of elements, especially those difficult elements. The first 20 elements, they are the ones that we are very familiar with, that we know how to write the electronic configurations. But those ones that are not among the first 20 elements, like those elements that are the inner transition elements, try to know how to write their electronic configuration, because they used to ask, they just say, what's the electronic configuration of this particular element? And the element will not be an element that you can write the electronic configuration normally. Also, you need to know about the periodic table very well. You need to know about it very well. The groups, the blocks, all these group 1, group 2A, 2B, 3A, 3B. You need to know all those classifications that are in the periodic table. Then you need to know all these unit cells. That's when it comes to structure of solids. You need to know the unit cells. You need to know all these body centered, face centered, all the properties of the unit cell for each of these arrangements. You need to know them. All these hexagonal close packing and the rest. Please try to find a good chemistry textbook that can explain all of these stuff. Now you can use chemistry, the central science, to read this particular aspect, or you use general chemistry. You can find these PDFs online. Just search for chemistry, the central science. You can download it, or you search for general chemistry. You can also download it to read your CHM 132. So that's for CHM 132. Please make sure you understand every aspect of what you are reading to, because they also have a lot of questions that are confusing. So then for GNS 112, I don't think there is much that we need to know from GNS 112. It's just what you already know. You already read part of it for semester, so you still just need to read it again and read your use of English. Mostly second semester is all about use of library. It's all about use of library. But since they have started surprising you guys in your set, you should read both of them for your GNS. Now for physics 192, physics 192 is very easy like physics 191. It's only your set that physics 191 is a little bit difficult. Physics 191 is always easy. Like they always ask questions from almost every aspect except it. But during your own set, I discovered that they ask major questions from heat, then little questions from the other aspects. So that means that you have to be very careful this time around also. So you have to read the practicals that you did very well. Read every practical. That's what I was saying the last time, that is every practical that you're supposed to read, not that you leave some of them out or you give some of them very little attention. Now, there was something that actually happened last year with physics 192. What happened was that during physics 192, instead of them to set 192 questions, they actually set physics 191 questions instead of 192. So a lot of people failed the course. They failed until later that they had to upgrade their scores. That's when most people now had A's. So what actually happened was that they set physics 191 instead of physics 192 for them in 192. And most of them have forgotten what they did in physics 192, probably because they crammed to pass physics 192. You see people that got A in 191, they were not able to pass 192 because it is 191 questions that are there. For me, it's actually supposed to be a bonus for you because it is something that you have done before. So be careful. Read 192 for 192. Read every aspect of it. Then read 191 also. Because the manual is not something that is too big for you to finish. You have other bigger textbooks that you have read. So try to read every aspect of 192 and also your 191. When it's time, I think I should release some videos on the tricks that you need for physics 192. Then for physics 142, that's atomic and nuclear physics. This is also a course that you think that you already know most about it, that you know about almost all of it. Because what are those topics that are there? They just ask you, you see, theory and structure of atom, Thomson, Rutherford. All these stuffs are what you already did in CHN 101, right? But you still have to read them again because there are some ways that they used to set questions. There are some logics that are important. And all these stuffs, another thing that is important about 142 is that all these atomic structure, Thomson, Rutherford, Bohr theory, all these Millikan's experiments, all this, anywhere you see experiments, please make sure you read that experiment. That's another problem students do have. They think that anything that is experiment, they don't need to read it. They just go and read the calculation aspect of the course. Please don't do that for physics 142. Don't do it for phase 142. Anywhere that you see experiment in phase 142, make sure you read it. Read the experiment, know why they did the experiment the way they did it, know the limitations of all of this theory, all this Rutherford theory, Thomson theory, Bohr's theories. Make sure you know their limitations. Make sure you know how they carry out. You know that Rutherford also carried out an experiment. That's how he discovered, he postulated his own theories. Not that he just said that let's be using this theory. No, that's not the case. There are actually things that happened that led to their theory. So make sure you know all of their theories, all of the experiments that they did for those theories. Then make sure you know the outcome of every theory, like the outcome of every experiment. Let me put it that way: the outcome of every experiment. So know the outcome of every experiment, know the name of the person that did the experiment, know why he did the experiment, know, even if you can know the year that they did the experiment, is very good. Know every subatomic particle, know who discovered which subatomic particle, know different stuff. There are many stuff that you have to know. Now for this, you have to then you have to be smart in phase 142. That's another thing. You have to be very smart, because there are times that they will give you, there might be very big formulas. You by the time you start, you will see what I'm saying. There are formulas that are very long in this particular course. There are formulas that are very long, so that you might even forget the formula. You might forget the formula, but what they will ask you is something that is very common. Just imagine they give you a lot of values, like up to like maybe 5 different constants. They will now say, find the value of the mass of an electron. Given all these constants, find the value of the mass of an electron. If you already know that the mass of an electron is 9.11 times 10 to the power of minus 31 kg, why should you calculate it again? So look at that. Some people, because they see different values, they would have forgotten that these things are stuff that they already know before. So they won't even do the calculation. Like they will forget that they are supposed to like just pick the value that they already know. They would have forgotten that they should just pick those values that they know. They will now try and be calculating it. So if they ask you to calculate anything, for example, they give you a lot of values, then they say find the value of the Planck's constant. Planck's constant is 6.26 or 6.62. I don't remember the value very well. Times 10 is power minus 34 joule seconds. Just pick it once you see it there. So there are many things that you won't have to calculate once you already know their values. They will now ask you to calculate it, trying to confuse you into using a formula that you have forgotten. Please don't fall into their trap. They like doing that thing a lot. So if you already know the values, just pick them and go your own way. Then for phase 142, you can read college physics, and you can also use university physics. University physics with modern physics. You can search it on Google. University physics with modern physics. That's what you read for phase 142. Read the lecturer's material also, please. That's very important. Make sure you read the lecturer's material. Then you should also know photoelectricity. Photoelectricity is also very important. Photoelectricity is important. Know all the calculations that are there. Thermionic effects also, during our no time, they didn't ask us any questions on thermionic effect. But during last two sets, they asked them questions on thermionic effect, thermionic emission. I mean, the calculations on thermionic emission. So try to read the calculations on thermionic emission also. And also try to read about the diode valve. Like read every aspect of the course outline and make sure you read them very well, so that you not be confused during the exam. And another thing, units are very important here. The units are very important. So for physics 152, so physics 152 is more tricky than, is trickier than physics 142. You have to understand it. Don't think that you already know it. And don't use any textbook that is not up to standard. Use college physics, use university physics. Then I should tell you something. Any topic that you want to read in physics, please, if you are using both college physics, if you are using both college physics and university physics with modern physics, read it in university physics before you read it in college physics, because college physics is more about calculation. They want to teach you the kind of thinking that you should have for you to be able to do calculations. That's what college physics is all about. But university physics is more of theory. It will let you understand the reason behind doing things the way they were done. So it's better you read a topic first in university physics after you have understood it to some extent, then move to college physics to solve their questions. I also discovered that most of your questions from physics 142, if not some of them, don't let me say most, some of them were actually picked from physics 142 and 152. Some of them were picked from university physics, especially in the electricity aspect. They used to pick questions from university physics a lot. So it's better you read university physics, then you read what college physics for calculations, and also read the lecturer's material. Now, most students are already good with electric field. Now, when I say that you are good with electric field, I'm not saying that you are exceptional. I'm not saying that you already know it. Please, you might think that you know it, but make sure you read it again. Even that thing that you think that you know, read it again and confirm that what you know is actually correct, so that you won't have problem during the test and exams. So it's very important that you read everything again. Now, the aspect that most people do overlook is the magnetism aspect, starting from this particular part. That is the most tricky, the trickiest aspect of the course is magnetism, because there are a lot of questions on directions. You used to ask questions on direction a lot. Which direction is the magnetic field going to point? If an electron enters a magnetic field at 90 degrees, how is the path of the electron going to move? If the electron enters the magnetic field parallel to the magnetic field, how is it going to move? Those questions are also common in physics 142 also. When it gets to all these Millikan's experiments, they used to ask those questions today. So it's important. These courses are not courses that you can cram. There are many things that you can memorize in physics 142, but you still need to understand some basic concepts, so that when they ask you questions on those concepts, you will be able to answer those questions. It's very important. And especially for physics 152, you need a lot of understanding of the course. Anything that you learn, make sure you learn it to the detail. Don't just learn it that I want to learn it to pass. Although you can learn it to pass, but you have problem during the exam, because the way they used to ask their questions, they don't ask questions that somebody that just read it vividly is going to be able to answer the questions, unless they decide to change this year. And according to what I've noticed in your set, things are not getting easier for you guys. Things are getting more difficult. So it's better you learn this the hard way. Learn what you are supposed to learn. Learn the logic behind all of these stuff. Because by the time they start asking questions, they can give you a graph of hysteresis and ask you which one of them is correct. They can ask you which one is for a magnetic substance, paramagnetic substance, diamagnetic substance, all of these stuff. There are stuff that if you don't understand them, you will never be able to pick the correct answer. And this aspect too, semiconductor, conductivity, mobility rectification is also very important. Every aspect of the course is important. So it's better you look for textbooks that really know about these stuffs. And different textbooks too used to use different convention. So it's better you use the one that the lecturer is using, which is university physics. Then read the lecturer's material too. Anything that you get from the lecturer's material, please don't say that it is wrong, because they are the ones that will set the question, and that's likely what they are going to set, and they are the ones that are marking it. So it's important that you know how to do things the correct way. Now for physics, for star 124 is easy. You have just one material for it. During our set, it was only one material that we read, but during other sets, they kind of like splitted that material into modules, although what is inside each module is different from what was inside our own module. But if whether you read that material or you read those new materials, you are still going to acquire the same knowledge. Now you have to be very fast with star 124. You have to be very fast. Although star department used to give people a lot of time, but we don't know what is going to happen this time around. All these random variables, know all the definitions that are here, because there are definitions, especially at the beginning. They will define random variable, they will find discrete variables like that. So you need to know the formulas, because there are also formulas there. Bernoulli trials, binomial trials, geometric Poisson distribution, like that. So you need to know all of the definitions, know how to solve questions under every aspect of the course, no matter where the question comes from. For those of you that did star 121 in fourth semester, that's for pharmacy students and the likes, you are going to find this aspect easier, especially when it comes to Bernoulli, binomial, geometric. You should find it easier, and maybe Poisson too. Maybe you did it, but this is a little bit different. And if you know how to use your calculator in this course, it's going to be extremely easy. And for phase 152 also, I forgot to mention that for phase 152, there is also an aspect of phase 152 that you can use calculator to do. I'm going to talk about that one later. The aspect is very long. When it's long, when you do it normally, that even if you are very fast, it will take you time to finish. But if you use your calculator, you finish it within seconds. So know all of these distributions, know the examples under them, know how to use calculator to do them, please. Know how to use calculator to do them because it's actually going to make you faster. It's going to make you faster. It's going to help you a lot, especially when it comes to probability density functions. That's when you know that you really need calculator. Now, statistics department, they are very smart in the sense that they know that you can use calculator to do some of these things if they give you table, especially something like regression coefficient. I can't recall the formula. I think it's n sigma x square minus sigma x sigma y. The formula is very long. The formula is very long if you want to calculate regression coefficient. So I think something like this, then over, there's another one on top, is long. So instead of them to now give you the table, they know that if they give you the table, you just enter the table into the calculator and get the answer. What they will now do is that they will give you the values. They will give you sigma x, they won't give you the table. They give you value for sigma x, give you the value for sigma y, give you the value for sigma xy, so that you won't be able to use calculator again. Then it will now come down to you now remembering how the formula is. If you can't recall the formula this time around, you miss it because your calculator can no longer help you out. So know the formulas, especially for regression and correlation. Know the formulas that you use to calculate them. Then also know how to use calculator to do them. So whichever one they give you, you'll be able to do it. Then for Math 112 is actually easy. It's just differentiation and integration. Then you need to know these maxima, minima stuff. They are stuff that you should know if you actually do differentiation. Then um all these Taylor series. He also has questions on Taylor series, Maclaurin series. They ask questions on them in Math 112. So it's important that you know how to do all of these stuff. And Math 112 has a lot of shortcuts. There are some differentiation that and integration that, especially integration, there are some integration that if you want to do them normally, they are long. But once you know the shortcuts, just use the shortcut and get the answer in only one step. You just take only one step and you get the answer instead of doing everything from the beginning. So it's important that you know all the shortcuts that are in your what Math 112. And as you can see, so it's also a 3-unit course. So it's important for you to know how to do it very well. Learn all the shortcuts, work with them so that you become very familiar with them. So know all these maxima and minima. They know how to do limits. Know how to do limits too is also very important. Every aspect of the course is important. Every aspect of the course is important. But the most important aspect is differentiation and integration, and also Taylor and Maclaurin series. Although they didn't put them here, but they asked us questions on them when we were doing the course. Because I can recall the only question that I missed in the test was a question on Taylor series. That's the only question that I missed in the test. So I can remember very well, I can recall very well that they asked us questions on Taylor and Maclaurin series. So try to know all the shortcuts. Then the last course here is what? Math 114. Math 114 is easy, but it's tricky. It's easy, but tricky. So read all the aspects that are there. Now, I didn't mention any textbooks for mathematics. That's because I used to read maths randomly around. So you can use engineering mathematics K.A. Stroud to read for Math 112. That's differentiation and integration. You can use K.A. Stroud to read for it. Please don't go and be using textbooks like HK Das. HK Das is too advanced for you in 100 level. So you just be wasting your time. So use HK Das to read this because HK Das is actually easier to understand what they did. Then for Math 114, all this mapping, bisection, composition, inverse mapping, know everything. Don't jump any one of them. Read each one individually and know the meaning of all of these stuff. And all these, I think there is inequalities here. Oh, now look at Taylor and Maclaurin series. Look at where they come and put it. They put it in Math 114. instead of Math 112. Taylor and Maclaurin series, I can recall very well that they ask us questions on it. So it is in Math 113. It's in Math 112, sorry, not in Math 114. So read it very well. Read it very well. Read all these fundamental theorem of equivalence, trigonometric ratio, sum, product formula, multiple angles. Why did they put trigonometric ratio in Math 114? Did you do anything related to trigonometric ratio? So I would like you to please confirm everything that is inside this course outline, because this is looking like course outline for Math 113. Sorry, Math 111. Yes, it's looking like Math 111. Multiple and sub-multiple angles. So check this course outline again for Math 114 and be sure that everything is there. Because where I know that Math 114 stops is this part. There is mapping, composition, inverse mapping, binary operation, associativity, invertive element, distributivity, relations, equivalence, like that. I know that everything is there. Then there is inequality. They don't put inequality here. There's also inequality in Math 114. So I don't know why this course outline is like this. All this height and distance in 2 and 3 dimensions. I don't think there's anything like that in Math 114. So please check the course outline for Math 114 again. This is where it's supposed to stop. And this Taylor and Maclaurin series is supposed to be in Math 112. And also, inequality is a topic that is in Math 114 that is not even in this course outline at all. So make sure you check the real course outline for Math 114. Please, I can recall very well that inequalities is in Math 114. And inequality in Math 114 is very tricky, especially when it comes to quadratic inequalities and polynomial inequalities, especially those ones that involve fractions of polynomials, is very tricky. There are ways that they used to answer their questions that you have to draw one ugly table like this. But I think I recall that there is a shortcut for that table also. So when the time comes, we are going to learn all of these shortcuts. So I think that should be all about your second semester courses.